Howdy Algebra, this is Miss Bird. This is my first video that I'm doing with you. We're going to work on function notation today. If you'll make sure to open your journal to your function notation page, we're going to start in the top left, the examples for function notation. Function notation is a way to differentiate or name functions. For instance, if we had y equals 2x and y equals 2x minus 1 and y equals 3x plus 7, we can't really keep track of which equation we are using with these two different equations. So, in order to tell a difference, we're going to change the y to function notation. So the y is changing, and it changes to things like f of x or g of x. You'll have a letter that names the function. That's the first letter, the f or the g, and you can use any letter other than the variable. And then inside of parentheses, you have the independent variable or the domain values. So the first one would be read f of x equals 2x minus 1, and the second one is g of x equals 3x plus 7. So the reason we do this is to keep our functions separate and to name them. This would be good if we were comparing two businesses, or if we had the profit from those two businesses that we need to keep them separate, or if we're looking at our height and I have two different people. Under the next tab, the domain and range. Remember, domain is all of the x values. And when we have range, in function notation, remember the y was replaced with the name of the function. So your range values are your f of x values. And we typically use the letter f, but remember that can be any letter. So the range is the f of x value. Under the next tab, evaluating functions. Functions can be evaluated in two different ways. Our first one, the function was f of x equals 2x minus 1. If we evaluate this, we would have for f of 8. Notice inside of the parentheses, we have the number 8. That means we are replacing the x with 8. When we plug this into our equation, we would have f of 8 equals, and then everywhere we see an x, we're going to put in an 8. 2 times 8 plus 1. So the function at 8 would be 2 times 8 plus 1. 2 times 8 is 16. 16 plus 1 is 17. So our function at 8 would be equal to 17. The domain here would be the 8 for x that we plugged in, and the range value is 17. It's what our equation is equal to when we've plugged in our number. Another way you may see these functions evaluated, for instance, if we had g of x equals 3x plus 7 when g of x equals 13. Notice this time we want our function, our whole function, to be equal to 13. So this is not saying that x is equal to 13. This is saying the entire function is equal to 13. If we have this function, when we have g of x is equal to 3x plus 7, and we need the whole thing to equal 13. So our function, 3x plus 7, is equal to 13. Now, they've given us that y value or the range value, and we're going to solve for our domain. When we solve for our domain, remember we split our equation into two parts, and we are going to subtract 7 from both sides of the equation. And we have 3x plus 7 equals 13, and then subtracting 7, that gives us 3x. Our 7's cancel out. 13 minus 7 is 6, so 3x equals 6. We divide both sides by 3, and that tells us that x is equal to 2. So our range value was 13, and our domain is going to be 2. The difference between these two things. In the first example, we had 8 in for our x value. So the 8 was in for the x value. In the second example, we were given 13 is what our function is equal to, and we had to find x. Under the last tab, Operations and Function Notation, you can evaluate more than one function at a time and perform operations on these functions. We're using the same two functions. In our first function, we're going to evaluate f of 2 minus g of 3. So for the first one, we had our function f of x. It was 2x minus 1. And then we're going to take this whole function and we're going to put in a 2 for x. So we'll have 2 times 2 minus 1. And we know that 2 times 2 is 4, minus 1 is 3. So f of 2 is equal to 3. Now, our second function, we're going to be subtracting this from our function f of x. Our second function, g of 3, our function value was 3x plus 7. We're going to plug in 3 for our function 3x plus 7. So we would have 3 times 3 plus 7. 3 times 3 is 9. 9 plus 7 is 16. So now we're going to take our function f of x, which we evaluated and got 3. We're going to take our g of x function, which we evaluated and got 16. So we put 2 in for our x value in our first function and 3 in for our second function for the x value. Subtracting 3 minus 16 gives us negative 13. As we evaluated these two things, we put our 2 in for x in our first function, and then we put 3 in for x in our second function. All right, the next one we're going to look at is operations and function notation. We have f of g of 2. As we look at this one, you'll notice that inside of our g of x is 2. This tells us we're going to put in 2 for x into our function g of x. After we find that solution, whatever its solution is going to go in for x in our f of x function. So taking a look at this, we're going to evaluate from the inside out. So we want to find our function value when g of x is 2. So we have 3x plus 7, that's our g of x function. We're going to put in a 2 for the x value. So 3 times 2 plus 7. 3 times 2 is 6. 6 plus 7 is 13. So g of 2 is equal to 13. Now, we want to find our function value for this in our f of x function. So we're looking for when x is 13 in our second function. Our f of x function was 2x minus 1, so we're going to plug in 13 for x. 2 times 13 minus 1. 2 times 13 is 26. 26 minus 1 is 25. This one can get a little bit confusing. We're working from the inside out. Remember, just like our parentheses go, we're working from our inside function out. The first thing that we did was we took 2 and plugged it into our function g of x. So here was g of x equals 3x plus 7. We put in 2 for that value, and we found that 3 times 2 plus 7 is 13. Now that value goes inside of our parentheses here, and we would be finding the function f of x equals 13. As we plugged in 13 for our f of x function, we put 2x minus 1, and then had 2 times 13 minus 1, which equals 25. We're going to work on function notation and operations in function notation again tomorrow in class. If you need to pause or rewind this video, please do that now.